Shoobity doop dop da doop dop doop. Today we're looking at Java Swing. Shoobity doop. I don't know what swing music sounds like, so that was my best guess. And yeah, I pulled a bamboozle on you after priming you for weeks with quizzes. They just disappear out of the blue. Who knows when they'll come back? Now you'll just have that sinking feeling in the pit of your stomach every day. It could be any day now they could come back and haunt me. But yeah, what if I just turned it around and said there was a quiz and this was all a lie? No, there's no quiz today, but there will be more later on. I expect we'll have something like 10 or 15 by the end of the semester. I've already started to drop some of the lowest scores, but the number will go up as we go. So I'll probably end up dropping like the lowest half or something. That's not a guarantee. It depends on how people do. Generally, when there's a quiz that everybody bombs, I add one more to the drop list. If there's a quiz where some people do well and some don't, then I keep it. So it depends. I try to make it so that it ends up benefiting everybody. The quizzes, again, they can't reduce your grade, but I'll drop so many by the end there, and that number will change. So just keep an eye on Canvas and look at your quiz grade. By this point, most people have like at least a C or better on the quiz grade, as long as you've taken more than a few. Someone asked, what if I do a quiz at the end of class? I won't normally, but there might be a couple of instances where I do. It's just kind of hard to disconnect, and we'd have to go over it the next time, so I prefer to do them at the beginning. Okay, today we are using that extra time that we're saving from quizzes to get into something that is rather complicated. Now, if you are behind at this point, so if you haven't been getting all this object-oriented stuff up to this point, well, this is probably your chance to catch up here, because this is where I feel like it clicks for a lot of people. So if you're still pretty confused, put your effort into what we're learning going forward here, and you might find that you suddenly get it. There is going to be a little bit of hand-waving at this point for some stuff that we haven't covered yet. I'll let you know when that's the case, but just be aware that some of this stuff we won't get to until later, but we need it in order to set everything up. Much like in 128, you used public static void main while completely glossing over public and static for quite some time, and then even void for quite some time. So hopefully you know what all those keywords mean now, although I know a lot of people are still struggling with static, and again, this is your chance for static to click as well. So what we're looking at today is called Java Swing. It's the graphics platform that's been built into Java for a very long time now. I think Swing is nearing its 15th birthday, and it is used today by almost nobody. So you might ask, why do we learn a platform that is used by almost nobody? Well, the reason it's used by almost nobody is because the age of the desktop application has kind of come to an end as well. So there aren't really a lot of apps that people use on their computer anymore. You've basically got your browser, some of the stuff that's built in there, like your image viewer and your notepad and such. You might have something like 7-zip. You might have something like Word or Steam. Obviously, maybe something like Discord. But even Discord and Steam have web clients these days, and so do most other apps. And Word has kind of given way to Docs and all these other different web platforms. So you don't see a lot of desktop applications in general. That said, if you used IntelliJ instead of Eclipse, remember I said that was another option with a better dark mode skin? That was originally written in Swing. So there was a time when Swing was pretty popular. But that brings us back to why are we learning it? Well, Swing is pretty easy as far as graphical user interfaces go. And if you've learned one, you've learned them all. They're all pretty much the same. They all have largely the same pain points and nuances. And more importantly, the graphics are a great way for you to get these object-oriented concepts that are the important bit. So as we move forward, remember that I'm not really that interested in your mastery of Swing. In fact, I don't really care if you become an expert in Swing, and it's probably not that valuable to you to do so. I care more that you understand the object-oriented elements of what we're learning. I'll also offer anyone who wants to do it the opportunity to work in JavaFX instead. JavaFX is Swing's successor. or at least Oracle named it as such. Swing, for some reason, is still included in your standard Java library, but JavaFX no longer is, which brings us to a very odd situation where you have to import stuff in order to use JavaFX, which is the main reason why we don't. But if you want to use the slightly more modern and slightly more often used JavaFX instead of Swing, you are welcome to do so. They are very similar in how they operate. Unfortunately, each of them are missing certain features that the others have, so there's no way to get the best of all worlds. And JavaFX, although newer, is not that much newer, and also still quite painful to use. Alright, so I'm going to make a package called Swing Intro. I've made a package called Swing Intro. I'm going to make a class called Driver to start. And then I'm going to make another class called Display, and this is going to be my graphical user interface. So one difference between writing programs for our Swing portion of the course and the portion that we've sort of just left is that the main method will usually just be used to set up our display panels, set up any external components, and link them to the display panels, and that's it. So you won't be doing much work in the main method from here out. So I'm going to set up our display panel first, and this is going to involve some of those magic words again that we're not going to learn for a while. So the display is going to extends jpanel and implements mouse input listener and key listener. So none of this will make sense to you at this point, and that's fine. You'll need to do some import statements in order to make this work. Just be aware that you do need to add this stuff to your display in order for it to work from here in. So don't worry about why yet. And then it will tell you that you haven't implemented some methods yet. Again, we'll gloss over that fact for now and just let it add those. And now you'll see we've made quite a long class already. So I'm going to repeat that process one more time here. So in my display, I said extends jpanel. Jpanel is a capital J, capital P. Java decided they were going to break their own naming convention here for some reason, and jpanel and other Swing components are pretty much the only classes in all of Java that start with 2 uppercase letters for who knows what reason. Mouse input listener and key listener. Both one words, both hard to spell. And then, of course, import everything. And then it will tell you you need to add unimplemented methods, which will make you a ton of junk. Okay, that's the initial setup. If there's any questions on that part, let me know in either chat. I'm going to take a quick poll to see if everybody gets up to that point. And remember, you don't have to follow along. I'll post this all to Canvas when I'm done. And starting very soon, I will begin synchronizing the assignments in class live so that you can just follow along on your machine. That'll start once we get into the graphical part in earnest. So, got to this point, or understand how to get to this point if you're not following along. Okay, looking good. Okay, now let's go back to the main method and do a little bit. Actually, let's make the constructor for display first. I'm going to make the constructor for it. So, in the constructor for a display panel, I like to take the width and the height. This lets you decide how big it's going to be, obviously, on your screen. And then I add an extra bit of flair to it. I take the background color. I've called it BG color here. So that's an optional thing. And then we're going to be using that built-in Java color. So I'm going to import it. That's another one of those things you have to import, remember. So I've added java.hot.color there. Remember, anytime you want to import something, and anytime you get an underline on a class name, and you don't have any other errors in your program, it's usually an import issue. So try that first before looking for other errors. Make sure that you've imported everything you've needed to import. And the display needs a couple of magical lines in order to get it started. The first one is going to be set preferred size, and the preferred size is taken not in terms of x and y, so you would think it'd be like this, width, height. That would be very convenient, wouldn't it? But Java actually decided to do one better. Java has another class that is very much like your point class that you've written for the homework, except instead of taking an x and a y point, it takes a width and a height, and they call it a dimension. So let's try that out. Dimension screen, or well, this isn't the screen size, it's the panel size equals new dimension, and it takes a width and a height. And of course, that needs to be imported as well. What's the advantage of using dimensions over just width and height? Well, first of all, you get one variable for both things, so you can access the width and the height by calling panel size.width or panel size.height. Notice that they made the field public here, which is not totally unusual, but a little less common in most of the Java libraries. So you can change the width directly, or you can use the setSize method to give it a new width and a height. Notice they've also got a few different ways to set the size. You can give it an integer width height, a double width height. You can give it a new dimension. So they've got a few different options there. And that's basically all the conveniences you get. You just get the sizes, the width, and the height on one variable instead of two, which means you don't have to keep track of the width and the height all the time. So if you wanted to, you could take a dimension as an argument instead of width and height. Just a little convenience Java added. But anyway, we're going to set the preferred height to the panel size here. We also could have done this in one line, like that, of course. We could have created the object inside of the argument. So either of those would be good. I'll stick with this version for now, since we haven't seen dimensions before. So that's a pretty straightforward command if you hover over the documentation for it. You might wonder, where did it come from? We don't have a preferred size method. Again, we'll gloss over that fact, but we've inherited it from JPanel, much like we inherit the default toString from object. We'll go into more detail on why that is quite a bit later. So for now, just realize that there's going to be quite a few of these inherited methods that you won't have to use outside of the boilerplate examples that I give you here. If we hover over its documentation, it says it sets the preferred size of this component. If it's null, the UI will be asked for the preferred size. That seems pretty straightforward. And then another one I'll show you is set background color, which sets the background color of this display panel to whatever we specify in the argument here, so to BG color. And there's a few more that I'm going to do later, but for now, let's leave it at that. So I'll go back to this constructor in a bit. Now, how do we actually get this panel to show up on the screen? This is probably the silliest part of Swing, is how much magical incantation you need to make in order to actually get the panel to show up. But now that we know a little bit about objects, some of this will make sense to us. So first, we need to create a new display, the object that we just made. So I'll just call it display with a capital lowercase d. And we said that it has to have a width, a height, and a background color. So I'm going to use just, let's say, 800 by 800. Now, depending on the resolution of your screen, most people are probably programming in 1920 by 1080, so this would be the whole screen. I have a 2K display, so it'd be a little smaller. Just keep in mind that if you specify in pixel units like this, the actual size of everything depends on the resolution of the person's screen. This isn't inches, it's pixels, so it depends how big your screen is. And then for the background color, I can pick one of those static colors from the color class. I told you these would come in handy quite a bit later. So let's go with, I don't know, let's go with beautiful pink. One thing you might have noticed is that all those static values in the color class have a version that's in all lowercase and in all uppercase. This is one of the only places in the Java library where it does this. They're exactly the same. It's just for people who prefer all uppercase constants and people who prefer to see their colors as lowercases. For some reason, they decided they were going to support all the same constants, but in lowercase as well. So use whichever you like. All right, so we've made the display panel. Now let's get to some of the magic. So the first thing you have to make is called a JFrame. This is a container for Swing parts. A JFrame is a container for Swing parts. And if you want to give it a name, my first, well, let's call it something better, a simple display. Say you want to give it a name. It can take a constructor like that, or it can take a blank constructor and then it will have no name. So those are two options there. We'll see what the name does in a second when I'm done here. And then we have to do a few more things. We have to do frame.setDefault close operation to jframe.exit on close, frame.add, and then we're going to add the display. I'll go over what all these do in a second. Don't worry. I'll do frame.pack, and then we'll do frame.setVisible to true. Okay, now we've got everything we need. If we run this, we get a beautiful, it's actually more of a salmon, isn't it? A beautiful display. Now let's go back through what all that stuff I just did meant. And again, you don't have to understand it for now. Just realize that in order to set up your display, you have to do all these things that I'm showing you today. And then the rest of it will be up to you, the picking up on the object-oriented elements of it. All right, so creating the new JFrame allows you to set the title. The frame is the part that contains the components. It's the part with the title bar, the minimize, the maximize, the X. That's a frame, right? So you can make all the visible components invisible, and then you're just left with the frame if you were to resize it. So a frame is just a container for other visual components. You could actually pack multiple displays, multiple panels into the same frame. So we work with panels. We usually do everything on one panel, but you can pack more than one panel into the same frame. That's how many UIs are made. You could also pack into this frame other components like buttons and sliders and things like that. Most of those we're going to attach to the panel instead. But when we call this frame.add display, we are adding our panel to the frame. How does the frame know how big to make everything inside of it? So we've added all of our components to the frame. Now it's got to figure out where to place everything, how to size it and everything. That's what that frame.pack line does. So we set a preferred size on our display in the constructor. If we omitted this line here, and we didn't set the preferred size of the panel, then when we launch this, we would get a non-existent frame. See it up there? Yep. It's very small. There. Okay, there we go. It's just the frame with nothing in it because none of the components were inflated to the size that they're actually supposed to be. So by setting the preferred size of the different components, when we call frame.pack, it says it causes this window to be sized to fit the preferred size and layouts of its subcomponents. So the frame will try to size itself in order to fit all of the stuff inside of it, and then the frame will size itself to accommodate all those different parts. And then the last line, if you omit that, pretty obvious things happen. If you don't set the frame to visible, which is kind of funny that you have to do, then nothing happens. It's not even on my screen. So you need to set the frame to visible in order for it to render. Now I skipped over this line, the default close operation line. If we omit that, not much happens. The reason that I put that line is for convenience. What happens when you hit this X? Does your application stop? No. If you don't omit that line, your application keeps going. And then every time you run this, you're going to have a bunch of applications running. The only way to stop the application at that point is to hit this little red square in Eclipse that says terminate. So this line here closes your application when you hit the X on the JFrame, and it closes it immediately, which allows you to not have to worry about it running in the background, you ending up opening up a bunch of them as you're debugging. So as you're debugging, all you have to do when you want to close it and start it again is just hit the X, and since you've got this in place, everything exits out immediately. All right, I'm going to do a quick poll and see if there's any questions on those magical lines. Some of these should make sense from what you've learned so far. Things like setting the preferred size. We have a very similar functionality in our rectangle class we used for homework there. I don't get too many yeses for the poll yet, so I'm assuming there's still some. Okay, most people picked picked up on the double negative, but yeah, feel free to ask if you have any questions here. If you don't want to set the title here, or you want to set it later on, you can also find the frame.setTitle method. Notice that since I set the title later on here, it'll overwrite what I did, and now it's called another name. So another way to do it if you don't want to use the setting up the name in the constructor part. Okay, so that gets the panel rendered to the screen, which was the hard part. And typically this is pretty much all we're going to do in the main method. So if we have other stuff that needs to be set up and linked together, something that we'll see is important later, quite a bit later, then we'll do it in the main method. But for the next few weeks at least, this will be pretty much it for the main method. We might have a couple lines here or there to modify something about the frame, but for the most part, this is going to be what all of our main methods look like from here out for a couple weeks at least. Okay, let's look at some of the fun things that we can do in our display panel. The first thing we're going to do is the simplest. We're going to draw a little rectangle to the screen. So display has this method that works very differently from anything that we've seen so far. We need to import in order for this to work. And that method is called paint component. This is another one of those inherited methods. It needs to be spelled paint component exactly, and it needs to use this keyword protected exactly. It will complain if you don't use that keyword and offer you to set it to protected. Protected is, for our purposes, the same thing as public, basically, so don't worry about it too much by definition. Things are protected by default. But yes, for your purposes, you can say it's essentially public. But we don't use paint component outside of the display class. So only the display class should access paint component at any time. Paint component will start with this line here, super.paintComponent. And this line, I'm going to leave a comment here. This line basically erases the screen and redraws the background. Okay, we'll learn more about what the keyword super means later again, but this line is important to erase the screen. Okay, and then we'll have one more line here, and that's going to be a cast. So you'll notice that the paint component method takes an object of types graphics as an argument. It takes a, I called it graphic helper, but it's, I could just call it graphics to be more consistent. It takes the type graphics as an argument. Swing actually supports two kinds of drawing. It supports drawing in 2D, and it supports drawing in 3D. Let's see if I have a question. Someone asked, isn't everything automatically set to protected? Yes, but you do need to specify it here for some reason. I'm actually not quite sure why they force you to specify it or it complains. I think because, I don't know, it wants the exact same spelling there. Maybe I'll figure that out. This is one of the only times where that comes up, that it must be protected in order to overwrite it successfully. Alright, so you get the 2D and the 3D graphics, and we don't use 3D drawing here, so we're going to cast our graphics tool as a graphics 2D instead. And just like you might cast a float to an int or something like that, you can actually do the same thing to the graphics here and cast it as a graphics 2D, and again we need to import that. So lots of imports going on. Notice I've really built up my imports already, and we'll have quite a bit more by the end of this. So I needed to cast it to a 2D. If you don't cast it to a 2D, so if you try to use the built-in methods on the original graphics object, you do have a lot of support for different 2D drawing, but then there's also a lot more that we don't need, so things like 3D rectangles and all that stuff. And so this is just a simplifying step to get rid of all of the 3D stuff that we're not going to use. I think there's also some stuff on a graphics 2D that's not accessible on the 3D variant. So we're going to use only the 2D variant in this class. All right, now what is this graphics object? So you can think of the graphics object as basically a pen or a writing implement of some sort. If you want to write things to the display, if you want to render things to the panel, you must be holding a reference to this graphics object. So there is only ever one in the panel. There's only ever one in the scene. It's the one that paint component takes as an argument, and it's actually automatically generated for you. We'll see how very soon. But this is used to draw everything that you want to draw to the panel. So if something wants to be drawn to the panel, it must get a reference to that graphics object. That means that all drawing for the whole panel actually has to happen in this paint component method in one form or another. So all the drawing that we do will happen here, or in a method that's called from here, which is how we're going to do it more often, so this method doesn't just become a blob. And we're always going to be passing that graphics object around. But again, it's like a pen or a brush or whatever kind of drawing implement you want to think about. If you're not holding the pen, if you're not holding the brush, you can't draw to the screen. And again, we're only going to be using that 2D variant of it for the most part. Okay, let's try to draw a couple of simple things using our graphics helper. I named it G for simplicity, just because I call it a lot. So let's draw the simplest thing you can possibly draw. Let's draw a line. We'll notice it's got 4 arguments, x, y, x2, y2. Okay, I want to draw a line from, let's call it 0, 0 to 50, 50. I'll draw a line from 0, 0 to 50, 50. Let's go. There's my line. You guys see it? It's beautiful. It's very small. All right. Let's say I want to draw a line to the middle of the screen. I want to draw a line to the middle of the screen. So this panel has properties that also it inherits. One of those properties that we can access very easily are the width and the height. And we can access those, as you might expect, from get width and get height. And this lets me draw a line from 0, 0 to the end of the panel. So it's going to go all the way across. Boom, we got a big line. How do I go to just the middle? So from the top left corner to the middle in either chat, how do I go from the top left corner of the display just to the middle instead of to the very end there? So how do I go from the top left corner of the display to the middle with my line? Go from the top left corner to the middle. Someone said divide by 2. You got it. I'm going to just divide by 2. Go to the halfway point. So whose width and height is this? It's the panel's width and the panel's height. Woo. All right. And as always, the keyword this can be inferred, but I like to leave it there for the added clarity in this case. Before you draw the line, if you want to make the line different sizes, you can change the properties of the line by setting it to a new stroke. The setStroke method takes a stroke object as an argument, and we'll see this a lot. We'll see the font method take a font argument, and there's different kinds of strokes you can come up with. Let's say I want a basic stroke. The basic stroke just lets you set a stroke of a certain size. What does that do? Well, it just makes the line thicker. So now I have a 10 thickness line. You can make fancier strokes like dotted lines and lines with different fuzziness and other properties like that, all kinds of other wonderful stuff with setStroke. So you can look into Java's stroke method if you want to see, or stroke class if you want to see more details on how to do that. Let's say I want the line to be a different color. Then before I draw that, I want to set my brush's color. Remember, G, the graphics object, is like your brush. So if you want it to be a different color, set the color to whatever you want. Let's say I want cyan here. Notice I used the lowercase just arbitrarily. Now I get a cyan line. So if you want to change the color of the brush, change it like that. You want to change the stroke of the brush, change it like that. You can do all this wonderful stuff. There's something like 50 different methods that G has, and you should get familiar with quite a few of them as we go through the rest of the semester. All right, let's do one more challenge task. Let's say I want to go from the middle to the bottom left-hand corner. So I want another line going from the middle to the bottom left-hand corner. I'll put it in chat. How do I get a line from the middle to the bottom left corner? Another thing to point out is that obviously lines draw either way, so if I said that I wanted a line between 0, 0 and half the width and height, that'd be the same thing as drawing a line between half the width and height and 0, 0. Obviously drawing in both directions, you end up with the same line. This way is the same as that way, there's no difference. Okay, let's try out the example in the chat and see if that gives us the line that we're looking for. Oh yeah, looking good. Okay. All right. Let's do a couple of basic shapes. So first, let's draw a rectangle. You've already got rectangles in your homework, so you know how they work. They use that first variant of the constructor that you came up with for your rectangle as well. They take an x, a y, a width, and a height. So when you designate a rectangle, you specify the x and the y. That's the x and y of the top left corner, just like on your homework. And just like on your homework, swing uses the same very backwards x and y coordinate plane, where, as you've already noticed from the line drawing, 0, 0 is the top left corner, and positive actually moves you down, which sounds confusing at first, but actually gets a little bit simpler to use at times, in my opinion. But it's definitely in the minority there. Most front ends don't have 0, 0 as the top left corner. They have it as the bottom left corner, as most people are familiar with in regular coordinate planes. So let's just draw a rectangle somewhere, let's say at 50, 50, and I'll make it 25 units wide and 100 units tall. I still have my stroke set to 10, so it's going to draw it very fat for me. Let's draw it in a different color. So I'll change the color of the brush before I draw the rectangle to, let's say, black again. And now we'll see that, first of all, the rectangle got drawn in that color. Second of all, drawing happens in order. So the brush got changed to cyan, we drew the lines, then it got changed to black, we drew the rectangle. That means the rectangle goes on top of the cyan line, so things get drawn in order. If you want something to appear on top of something else, all you have to do is make sure that it gets drawn later, and it will be drawn on top of it. So let's do a relatively complex challenge here. Let me open up Paint and show you what I want to do, and then you'll show me if you can figure out how to do it. So let's say I want to draw a square that is completely centered like this inside of the display. So I want it to be perfectly centered in the display. How do I draw, in either chat, a rectangle that is perfectly centered on the display like this? So remember that first coordinate we're specifying is the top left coordinate. So it's going to be up there, and then assume that this in the middle here is the perfect center of the display. So your goal is to figure out this point, and then what to make the width and the height in order for it to be perfectly centered like that. So let's say for the challenge we want it to be some scale of the screen. So let's say we want it to be 1/4 of the screen big. So let's say we want it to be 1/4 of the screen big and directly centered. That's the goal that we're looking for the challenge. So we want a square that's 1/4 of the screen big and precisely centered. This is mostly a math problem, but we'll run into a lot of these as we go with graphics. And then we'll look through it a little bit, see if anybody gets it. So that's 0, 0, remember? That's going to be 0 max. This point down here is max max, the width and the height of the screen. And then that point up here is max 0. Okay, so this point in the middle here is width over 2, height over 2. That's the point directly in the center. The rectangle's dimensions, it's going to be obviously width big and height tall. We'll call this rect width to differentiate it. So it's rect width big, rect height tall. So how do we draw that rectangle in the middle of the screen like that? Rect width, rect height. Maybe it'd be more straightforward to call this width height instead. That's width height down there. That's width 0. That's 0 height. Swing coordinate planes. How do we draw this centered rectangle as we have it? So first I said it would be a quarter of the screen big. So rect width is obviously going to be equal to width over 4. And rect height is going to be equal to height over 4. So we can easily determine those. Okay, so assuming that we have those variables, how do we get this top left corner up there? Once we have the top left corner, since we already have the width and the height, we can make the rectangle from there. So the only thing that we need is the coordinates of the top left corner. Now we know the coordinates of the center point. It's width over 2, height over 2. How do we get from that to the top left corner? Well, we obviously need to subtract by this distance here and also this distance here. How do we figure out what these two distances are? What's this distance and what's that distance there? Remember, this whole distance is the rect height, which was also the height over 4. So what's half of that? Well, it's obviously rect height over 2. Okay, what's half the width? Well, that's obviously rect width over 2. So we figured those out. All right, so with those two lines and the center point, putting it all together, how do you get the top left corner in either chat? I'll leave this to you guys to figure out. So I'm going to tab away from this picture to start writing my rect width and rect height and everything. So how do you get the top left corner in either chat? Okay, so I have the center of the screen. Let's say my goal is still to draw that rectangle in the middle. So I'm going to say rect width equals this dot get width divided by 4. And rect height is this dot get height divided by 4. So then what is the x and the y? Obviously the width and the height are those two values I just made. What are the x and the y values of the rectangle here? Back to the test image for a second. So if that's width over 2, height over 2, and these two lines are rect height over 2 and rect width over 2 big, how do we get to that point there, the top left corner? And you can bet that something silly like this will be a quiz one day. Those two values there. Leave this open off to the side. Well, let's try the one answer that was posted. Let's try that. So something like this. It was, I guess, this for the x and the y. And then I already did that for the width and the height. I just saved them to variables. So, well, actually, I already saved these to variables too. So I just call this, let's say, rect width and rect height. Okay, so let's try that out. Not quite, right? It's top left corner is a bit off. Bottom right's in the right place, though. Not really. That's where the top left should. That's what the center should be. So what do I do to shift it over to that top left region that I want? If you end up doing a lot of front-end framework, or a lot of front-end work, front-end being the graphical component of the programming universe, so making your buttons and your drop-down menus and screens and all that good stuff, you'll end up with a lot of this kind of stuff to do, figuring out how to place things where you want them. Let's try the other answer that I got. I got the this dot height over 2 and this dot, this dot width over 2 and this dot height over 2 variant. So let's try that out. This is closer. We now have the square's top left corner perfectly centered on this point. Now all we have to do is translate it over to there. If you worked with processing in the past, this is why processing has a convenient feature that allows you to switch your rectangle placement mode to centered, so you can specify the center point instead of the top left. But Swing wants you to specify it in the order top left and then width height, and that's how it makes rectangles for you. So how do we translate this top left point over to where it needs to be exactly centered in 1/4 of the panel big? This is correct. We're just going to add to it. So what we have here is right. We're just going to add a little bit more to it. Remember, we've got these rect width and rect height variables, and we figured out that the length of these two segments is proportional to those. This one's rect width over 2, and this one's rect height over 2. So it's got something to do with that. In fact, it's got everything to do with that. We got our translation that's happening here, the translation from the middle to the corner. How big is this translation that we're doing? That's the question. So how much are we translating on X? How much are we translating on Y? That hard, huh? Well, I know that your previous year's 128 didn't have a lot of graphical elements to it. In the past, this question usually goes over a little bit better, so I have to take it easy on you guys with the graphical questions. Seems you're definitely a little unfamiliar with that world. Let's see. Got a couple of guesses. The get width times 2. No, not quite there. All right, I'm going to give it away because this is a bit of a struggle so far. So we are, let's use the paint version first. We are translating from the center over to this point. That means along the x-axis, we are subtracting half of the width of the rectangle. So along the x-axis, we're moving this way to the left, and we're subtracting half the width of the rectangle. And on the height, on the y-axis, we're moving up. And remember, up is negative in swing, so we're actually subtracting half of the height of the rectangle. So to translate from dead center of the screen, which is width over 2, height over 2, those refer to the screen's width and height, we need to subtract half of the rectangle's width and half of the rectangle's height, which are already variables that I had set up here. So we're going to subtract half of the rectangle's width and subtract half of the rectangle's height. This is something we're going to do relatively often in order to center things around a point. So if you want a point to be the center, the algorithm is like this. So if you want a rectangle centered around some point, let's call it x, y, then you typically do x equals, and then we'll call this rectx to be less ambiguous. Rectx equals x minus rect width over 2. Rect y equals y minus rect height over 2. And this allows you to center your rectangle around some arbitrary point, in this case the center of the screen. And we'll notice that this remains centered even if I change the size of the panel. So if I go to the driver and I specify that I want a panel that's 800 by 1500 instead, the rectangle remains centered. If I want a panel that's, let's say, 400 by 800, the rectangle remains centered, and our line remains drawn correctly too. So if I want a rectangle that's 800 by 400, it still remains centered. If I do some kind of odd numbers, like I don't know, 800 by 600, then it's still going to remain centered. Lovely. Okay, let's go back to a square panel then, just for simplicity. So 800 by 800. Okay, so something to think about. All right, back to looking at other different swing utilities. So there is another one to draw ellipse-like shapes. That's going to be DrawOval. And this one has kind of a weird specification for the coordinates. Let's say that I use the same coordinates that I used just now for the rectangle. So I'm going to specify my ellipse in the same way. You'll notice that it's just circumscribed inside of the rectangle. So what the ellipse does is the x and the y that you give it are the x and the y of the box that would be around it if it had a box around it, the top left corner of that box. So really confusing. Again, one more time. If you were making an ellipse, let me make a new thing in Paint. If you were to make an ellipse, which doesn't necessarily have to be a circle, by the way. An ellipse can be an oval too. It can be taller than it is wide. Then the x and the y of that ellipse, according to swing, are the x and the y of the box that would be perfectly around it. So let me make sure that's perfect. It would be this coordinate right over here. So it's that top left coordinate is what we're talking about when we make an ellipse. So a little bit confusing, but as you'll see, it's actually much more intuitive than using the center most of the time. So likewise, if we want an ellipse to be centered, so actually I can change this comment to be a shape centered around some point, then you would typically use the shape x equals x minus the shape width. That's the shape height. Okay, so I'm going to do a quick poll again. Understand how to center shapes around some point. Yep. Nope. So that's drawing shapes. Drawing shapes means drawing their outline. There's another tool that you can use to fill shapes in. So instead of DrawRect, if you use the tool FillRect, and let's go ahead and fill it at the coordinates that I've given again in the center, then what you're going to end up with is a filled in rectangle without the outline. So if you want to draw the outline and the fill, you would actually have to do both, draw and fill, so if you want a filled shape. Now, of course, I need to change it to a different color, so let's call it white. Okay, so let's say I want it to fill in white. Well, there we go. Two problems here. First of all, the stroke is not the size that I want it to be. Someone asked, would you just use the same coordinates for both shapes? Do you mean if I want to draw and fill at the same time, if I want to make a filled shape with an outline, would I just use the same coordinates? Or do you mean if I want to make different shapes or something? So the problem with the shape that I've drawn here is that I wanted a size 10 stroke around the outside. The answer is yes. Yeah, if you want to draw a filled shape with an outline, you would just use the same coordinates. But if I want to draw a filled shape with a size 10 stroke, I need to make sure that I draw the outline after I draw the inside. So I actually have to reorder this, and I have to move my outline drawing at the end. And I need to, of course, change the color back to black since I had changed it to white earlier. And then I get a size 10 stroke for the outline. So if you look at the previous execution I ran compared to this one, it drew the stroke first, and then the fill actually went over most of it. In this case, I drew the fill first and then the stroke over it. So in either chat, one more challenge here. Let me ask, how do you draw, let's say, I'm going to type this out in general too. How do you draw, well, I guess I can say what order would you draw to get with stroke size 10 borders, an ellipse in red, cyan outline, rectangle around it in blue, and green outline. So I would like to see with all size 10 strokes, an ellipse in red with a cyan outline, and then a rectangle around it in blue with a green outline. What order do I draw them in order to accomplish that? And of course, you have the same thing for oval. You can fill the oval too. Well, just avoid that for now. Okay, and this is how you would draw very, very simple shapes to the screen. But we're not going to do this too often. What we're actually going to do is create our shapes as objects instead of drawing them like this. So let's look at how to create a simple shape object while you think about how to solve that crazy puzzle. Well, I guess let's solve the puzzle first and then move on. So I want to draw the oval first. Let's say g.setColor, color.red. Okay, so I want to draw the ellipse. Then I'm going to copy this and draw its outline. This is not necessarily the right answer. I'm just typing everything I need out so that you can tell me what order it's going to go in. And then the rectangle was supposed to be in blue, and then with a green outline. So is this the right order? I got the inside in red, and cyan, blue, green. Let's see if I get everything the way I want it to be. Oh man, my oval's gone. See, I bet you thought that was going to be the right answer, but no. That draws the oval first, and then draws a square directly on top of it. All right, so oval last, so let's copy all the oval stuff and make that last. Let's see what happens there. So we got rectangle, fill. Okay, two problems. The oval stroke is obviously not size 10, it's smaller. And then the rectangle isn't on top of it. The oval is on top of the rectangle. We wanted the oval inside the rectangle. So the rectangle should be around it, the oval should be inside the rectangle, and the oval stroke is obviously not the correct size right now. We should have that full 10 stroke size outline on our oval too. What goes before the rect, but after the square? So the pole. Well, there's two for the oval. There's a draw and a fill. Sometimes I accidentally use the word square instead of rectangle. Just assume I'm an idiot and think those are the same. Whoops. Missed an apostrophe there somewhere. Okay, which one goes last? The confidence here is low. Rect draw is the, looks like, prevailer so far in who goes last. So let's try to reorder those. Alright, so rect draw is last now. I've got most of it solved, it looks like. The oval's now inside the rectangle. The only thing that's wrong now is that the stroke size of the oval is still not right. It's still a small stroke instead of a size 10 thick border. So two more things need to flip. So the oval, draw, and fill need to swap. Let's see. Oop, I pasted the wrong thing. Grab the color before. There we go. That's right. That's what I'm looking for. Beautiful. Okay. One more tool, I guess, before we move on to the objects. If you want to draw some text to the screen, it's simply draw string. You say what you want to draw. This is some text, and then the location you want to put it at. So let's say 100, 100, and it'll draw in the same color as the brush or the pen or whatever it is. So here it is. It's very, very tiny. You can't really see it. I'll show you how to change the font size later, because that is unfortunately a pretty annoying command. Let me change it to a brighter, darker color so it's better to see. Let's go with black. There you go. This is some text up in the corner there. Alright, so on to objects. How to make objects. The first object that we're going to look at is going to be a simple rectangle, just like the one that you made on the homework. It shares many properties with the one you made on the homework. But the annoying thing about Java is that it has actually three very similar classes. It has a class called rectangle, and we're not going to use the class called rectangle because it lacks a couple of features and it has a small problem with precision. I'm going to show you what I mean. Well, let me show you another day. get to the rectangle today. So the class that we're going to use is called Rectangle 2D, and then there are actually two variants of it, which are basically the same thing. There's rectangle2d.double and rectangle2d.float. The reason that they made two variants is because I guess they noticed that some developers used float for all of their front-end work, and some used double, and they decided to accommodate both, so they just made two versions, which is kind of unfortunate because it makes the object's name very, very long. It's now rectangle2d.double, which is probably the longest object name we've run into yet, and the only one we've run into yet that has a dot in it. So sorry about that. That's just what rectangles are called in Swing. They're called rectangle2ds. Doubled. So I'm going to call this, let's call this top left rect. And to make one, you put exactly what you would expect in the constructor, same thing as we had to do for the draw rectangle down there. It's going to be the x, the y, the width, and the height. So let's say I want to go 50-50 and I don't know, 100 by 100 big. So I'll make a square there. Okay, so I've created a new rectangle, but if I was to run this now, then nothing would happen with the rectangle that I created because it doesn't exist on the screen yet. Again, for anything to exist on the screen, it must be drawn somewhere inside of the paint component method. So I'm going to make a little comment here. Messing around with drawing functions. And then over here will be drawing shapes to the screen, or I guess we can say shape objects to the screen. So if you want to draw the rectangle that we called top left rect to the screen, the process is very simple. We're just going to say g.draw, and then you'll notice that there's a version of draw that takes a shape as an argument. And all of the basic shapes, including rectangle 2d.double, which I'm usually just going to refer to as rectangle, inherit from shape, and so can be used wherever you want to specify a shape. So I can say g.draw the top left rectangle, and it'll draw it for me over here. So there it is, and its default stroke and everything. Let's change the stroke further up so that you can see it better. I'm not sure if everybody can see those tiny little lines. Let's call this changing brush properties. Set it to black. Okay, so there's my little rectangle object being drawn to the screen. Wonderful. I can also place it somewhere else. Let's say I want to put it at 100 instead. So now it'll scoot further down here. Let's say I wanted to place it at 100, 400. Let's scoot over here, fine. But let's say that I want to put it at, I'll go back to my paint test example. Let's say I want to put it exactly in the top right-hand corner of the screen. It's a perfect square. So I'm going to put it exactly in the top right-hand corner of the screen up here. Well, you'll notice that I don't have access to the width and the height over here, right? So I would have to place this rectangle in the constructor. So let me do that. Let me do top left rect equals new rectangle 2d.double. And then I'm going to specify, I'll give it some preset width and height. So let's say it's going to be 50 by 50. But I want to put it in that top quarter of the screen. So you might be tempted to call this dot get width here and this dot get height here and place it in the top right corner, or sorry, the top left corner that way. And this won't work. And the reason that it won't work is kind of dumb. It's, I guess, a glitch with JPanel and with Swing. It's that the get width, get height, and all of the other methods of the panel are inaccessible until the constructor is completely finished. So until the constructor is done, and actually until the frame is packed, which happens much later than the constructor. If the constructor happens on line 10, the frame isn't packed until later. Until the frame is packed, you can't get its width and height. Those properties don't exist. So if you wanted to say that a rectangle will be at that width and height once the panel is made, what you can do is use the width and the height that you already got as arguments. And that's why I take those as arguments too, so that we can use them as arguments here when we designate the rectangle's location. So just a caveat to remember that get width and get height do not work inside the constructor. None of panel's methods, for the most part, work inside of constructors until the panel's done. So now we've got it in roughly the right place. And remember, if you want it perfectly centered in the top quarter of the screen, you have to subtract half of the width and half of the height, and then you get it to be perfectly centered in the top quarter. Let's make a few more and do the same thing. Let's have a top right. We'll do a bottom left. And we'll do a bottom right. Bottom left and bottom right. And then just paste those in 4 times. Top right, bottom left, bottom right. Okay, well, how do I get to the top right? Well, that's going to be 3/4 of the way over. What if I just do 3 times? Doesn't that get me 3/4 of the way over? Yes, it does. 3/4 of the width. 3 times the width over 4 is 3/4 of the width. And of course, we still have to remember to subtract half of our rectangle's width and height. Okay, how about on the bottom left? Well, then it's 3/4 of the height, so 3/4 of the height. And on the bottom right, it's 3/4 of both the width and the height for the x and the y locations. And if I run this, none of them will show up on the screen. Why not? Why haven't the other 3 rectangles shown up on the screen yet? Did I put them in the wrong place? What did I forget to do for the other 3 rectangles that have not shown up on the screen yet? What did I forget to do for the other 3 rectangles? I'll leave a comment here in the meantime. You can set your rectangles up in the panel's constructor to place them in specific locations. Just remember, get width and get height methods inherited from the panel do not work in the constructor. Use the local variables width and height instead. Yes, I forgot to draw them in paint components. Somebody got it right. Every time you want something on the screen, you have to draw it. So top left, and then top right, bottom left, and bottom right. Okay, so now I should have those rectangles in all 4 quadrants. Awesome. And if I wanted to fill them with some color, it would be the same thing. So I could do g.fill and fill them in. Let's try a different color. So set color, color.red, and I could fill them in the same manner. So now I have it in solid red. And again, if I wanted the outline to go on top of the fill, all I would have to do is fill them first, and then make sure that I switch back to black for my outline stroke color. Ta-da! Okay, so that's rectangle objects. There will be others as we go through. It'll be ovals and different things like that. So next time I will show you how to use the mouse and keyboard in order to do things in your JPanel, in your display. We call this a JPanel. And I guess the last thing that we can do today is try to simplify our drawing a little bit. And this is something that a lot of people did on the homework. Instead of having 4 points, you made probably an array of points. Let's do the same thing here. Let's do a rectangle 2D double and call them rects. A very awkward declaration, isn't it? So what's up with that? How do I finish this array declaration? There you go. Just want to point that it's a little bit weird, you know, having a class name that has .double in it is a little bit weird. Can you do this? Can you just do this? Yes, you can. As long as you specify the .double on the right-hand side, you can omit it on the left-hand side if you find that it makes it clearer for you. Okay, so if you prefer it that way, do it that way. I will probably include the .double at least early on so that you can get used to the fact that you have to have it when you create it. From the constructor side, well, I guess let me take a poll. Which side is more readable to you? What's more readable to you? Having .double on the left or omitting it? To you. Some people prefer that the right and the left-hand sides match. It is able to infer without it, but obviously you end up with very, very lengthy array declarations like this one. So awkward. All right, if you prefer the .double, we will keep it. Okay, so I've made an array of 4 rectangles, and then rather than specifying each of the rectangles individually, I did this in some of the other examples earlier, like bomb. So I could have integers that represent each of the indexes here. So let's say top left is 0, top right is 1, If you didn't do this already, by the way, you don't have to. I'm not knocking you for bad organization unless it's especially messy. So even if you just had 4 points and you did everything with 4 points, I would take off a little because I think I specifically said you had to have an array, but I wouldn't take off much for that. Okay, so then I get rid of these, right? And then rather than doing it like this, with each of them being an individual rectangle, I would say something like rect of top left, which is nothing more than rect of 0, but I've specified it, sorry, rects of top left, but I've specified that index 0 has a name so that I can remember it more easily. I'm going to do the same thing for the other 3. So there's your top right, your bottom left, your bottom right. Now I have them all in one array, and I have a very easy way to refer to them. And now when I go to draw them, right, instead of having to g.draw and g.fill each one individually, all I have to do is go I equals 0, I is less than rects.length, I plus plus, blah, blah, blah. And then rects of I gets filled in. And likewise for the draw. Fill them in and draw them. And that draws and fills in all 4 rectangles. Whoopsie daisy. Okay, did something wrong there. Well, we'll fix that next time, and then I'll post it to Canvas later. Alright, so yeah, next time, mouse, keyboard, all that other fun stuff. Keep on playing with Swing. I'm going to post the first Swing homework tonight, and it won't be due until next Thursday, but try to get a head start in it. You won't have everything you need to do it until next class, but you'll have a lot of the material you need to get started already. It might help you to familiarize with Swing a little bit in advance. Okay, that's it for today. See you later. Wait, is that it? No, it's not. We still have like... No. That's it, we're done. 75-minute class. False alarm, everybody. You are done with class. Goodbye.